So thank you ICTS for giving us time to present our system from Oxford Instruments. So Oxford Instruments is a company uh, which started in 1959, and one of the first product which was commercially available from Oxford Instruments was superconducting magnets. And eventually, parallelly, factory was into superconducting magnets as well as some low temperature systems like wet fridges, then wet dilution refrigerators, wet dilution sticks and all. And eventually, company added few more other. They got in few more companies which were into other different fields. But over the time, one of the main goal of the company is to enable high-end advanced research, and it's not just into quantum technologies, but also into life sciences, semiconductors, into advanced materials. So various fields are where we provide systems. So currently, if we see our portfolio, the first one is nanoscience, to which I belong to, but our portfolio also includes systems for like plasma technology, which is into etching and deposition systems. Then we have Asylum Research as a division, which is for atomic force microscopy. We have recently taken over VTech, which is into confocal Raman microscopy. There are right now 9 different divisions catering to different applications. Now I will be more focusing on the nanoscience division. Yeah, just to reiterate what I said. So whether when it comes to fabrication or let's say qubit development or transport measurements, or whether it's a surface characterization or single photon detectors. So this is a whole range of systems we cater to at different stages in the research. So when it comes to dilution refrigerators, it is one of the core product of our company and our division nanoscience. So you can see that from 1966 till now, we have developed this dilution refrigerator capabilities with respect to the kind of materials which are available, the kind of development in the cryogenic technology which has happened over time. So initially it used to be like small fridges with less cooling power and very limited number of wires. But now you can see that by now we have far more bigger fridges which can handle more number of RF lines, far more cooling power, and like more user-friendly things. Before I go into like the product line of like dilution refrigerator, what we have, I will just want to highlight 2 things about this, 2 slides on the use of like how the dilution refrigerator is. So we all know that when we have liquid helium has a base temperature of 4 K. So when we pump liquid helium, what we can achieve is 1.5 Kelvin. Now, if we have another isotope of helium, which is helium-3, and if we pump helium-3, we can reach to 300 millikelvin. Now, it is like with helium-4, we can reach to 1.5 K. With helium-3, we can reach till 300 millikelvin. Now, if we have a mixture of helium-3 and helium-4, and then if we cool down that particular mixture further to less than 300 millikelvin, what we see is a phase separation. And that phase separation happens below over here, what we see. And that phase separation results into 2 layers. One is the helium-3 layer, and one is a helium-4 layer. Now this helium-4 layer still has certain percentage of atoms of helium-3. Now if we pump above this layer, if we keep pumping on this layer, some atoms from this helium-4, helium-3 atoms in this layer will go into the pure helium-3 layer. And when they are moving from this layer to the next layer, because when we are pumping it, there is further decrease in the temperature, and that is how we reach millikelvin temperatures. This is what we can see from a typical system. Like what we have outside is a vacuum. The blue line, what we see is the 4K, that is the liquid helium. And then inside it, there's this circuit. This is a helium circuit. If we have this circuit helium, it is anyway going to be at 4K. Then if we pump it, this will go to 1.5K. Now, if we have another circuit with helium-3, helium-4 mixture, and if we pump that mixture as well, so initially this will reach to 1.5K, and with the continuous pumping, there will be a phase separation over here, and this phase separation with further cooling will result into temperature of 10 millikelvin. Now this same thing is over here. This used to be called as wet fridges because outside what we see that the 4K layer is because of the liquid helium. Now that 4K layer, that 4K temperature is now replaced. I mean, this liquid helium is replaced by PTR, pulse tube refrigerator. So this pulse tube refrigerator is now going to give us this 4K. Then inside it we will have another loop for helium-3, helium-4 mixture. So initially it will get cooled to 4K. Then the cooling will result into 1.5K, and then further pumping will result into phase separation, and that is how we reach millikelvin base temperature over here. That side, now you can see that in the dilution refrigerator, why there are these stages. So first two stages are this PTR stages, the 50 Kelvin and 4K. Then this 4K is transferred to other plates. Then using heat switches, these plates are isolated from the 4K stage. And then we have this another loop, which will have helium-3, helium-4 mixture. And that is how we reach 10 millikelvin at this particular plate. So this plate is a mixing chamber plate where we'll have that mixture separation happening. And below this plate, whatever mass which we want to cool down, that will be attached on this plate. And then we can also have a magnet, superconducting magnet, which will be attached to the 4K plate. Now, from these slides, what we can make out is that the amount of helium-3 in that mixture decides like what is the cooling power, cool down time, and then the structure over here will decide like how much amount of mass you can attach to the mixing chamber plate, and how much number of RF and DC lines you can manage. So what, I mean, this is the basic structure of any dilution refrigerator, like our dilution refrigerator. And what we have done like with the new model is that whatever experiments which require the RF lines, so those are on this particular line, which we call as secondary insert. Now all our RF lines will be attached from top to the mixing chamber plate on this secondary insert, and this secondary insert can easily be taken out from the system and then again placed inside the system. Now the main purpose of this is that when you have certain kind of experiments where let's say you want to change the circuitry of the RF lines, you want to add some more cryoelectronics or some other things on these RF lines, you can take out this part, do all the circuitry changes outside at room temperature, check your experiment at the room temperature, and then once that is all fixed, then you can put it into the fridge. Also, you can have another secondary insert which with separate different RF lines and different circuitry. Let's say you are working, your experimenter right now is happening with certain number of RF lines and coax lines, and then you have another secondary insert which is outside, and then you are putting all the RF lines, doing all the like all the electronics which you are putting it, you are testing it outside. Then once that is done, you can just replace this secondary insert with the fridge. So this gives you a kind of modularity and kind of you can swap between different experiments instead of having multiple systems, or else you can have multiple systems and with multiple secondary inserts, so that you can have different experiments on a particular secondary insert, so that multiple users can use the systems. Now that same capability of secondary insert is something which we have now added, and we have scaled up to far bigger systems, because generally in quantum computing, specifically in superconducting thing, where we need whole lot of more of RF lines. So now if this fridge can handle up to 128 coax, we can have another, a bigger fridge which can handle 2 secondary insert. Now one secondary insert here can handle 128 coax. So because this fridge has ability to handle 2 secondary insert, so it is like double the capacity. Similarly, when you have when people want to scale up to 500 qubits or let's say 1000 qubits, where they will require more hundreds of coax lines. So that is point where 4 QX will come into picture, where you will have still at least 4 secondary inserts which can be attached on this system. And all these secondary inserts are swappable between each systems, like whether it's MX or LX or RQX. This is just an image of our system. Yeah, and now till now what we discussed about this RF lines. So that is like when you want to scale up to more and more number of RF lines, specifically into quantum computing. But when it comes to 2D materials or graphene kind of applications, where there is not much requirement of higher number of coax, but maybe a limited number of coax, but um, um, that is where we have this Proteus S comes into picture, which is less number of, the number of coax which you can handle is lesser, but what it provides is a far lesser cooldown time. So a bare fridge of Proteus S without magnet can cool down from room temperature till 10 millikelvin within 17 hours. And then for certain experiments, we also have Proteus 5 millikelvin into our portfolio, which is now have been added. Yeah, so this Proteus S is specifically for people who are into this transport measurements kind of thing, where you will have a magnet at the bottom of this mixing chamber plate, and because the sample space is generally limited by the magnet, so having a certain smaller fridge is definitely no problem. What it better provides is a better cool down timing for the experiments. And we have an option of 12 Tesla as well as 611 vector magnet for this Proteus S model. Apart from this, like as our main thing is about superconducting magnets and all, so we have a Spectromac PT system, which is mainly for the optomechanical and optical transport measurements, where you will have a 7 Tesla magnet at the bottom and 4 optical windows. And we also have Teslatron, where you can have from 8 Tesla till 16 Tesla solenoid magnet system with a VTI of 1.5 Kelvin. And with this system, you can have probes which can go till 300 millikelvin as well as 25 millikelvin. Yeah, so this slide represents like recently all our milestones. So when it comes to different collaborations, so because this quantum computing and all this arena is developing far quickly, so we have been doing some collaborations with different universities and companies like to develop systems as well as to have those systems into different data centers. So recently, one of our collaborator, our collaborator OQC, Oxford Quantum Circuits. So they have a fridge which is now available on AWS Braket, and it is a 32 qubit system which is right now available. Yeah. So that's the thing. Thank you.
So I'm Rizwan from Laser Science. I would like first to thank ICTS for this opportunity for making time for us. So we'll start with a quick introduction to our company and what we do and what are our capabilities. So Laser Science was founded in 1988 by Dr. Lalit Kumar. So Laser Science, as well as I was mentioning, was established in 1988 by Dr. Lalit Kumar. And ever since then, we are one of the leading companies in the scientific market, supplying various systems from different partners we have from abroad. So our vision is to bring the latest technology to the country, to the scientific industry. And our mission is providing very efficient service, and we are renowned for our service across the country. So we are partnering over 25 principals worldwide who are the leading manufacturers for lasers and various other systems. So we started our company with Coherent, who is one of the leading manufacturers of lasers and laser-based systems. Laser-based systems. So Coherent supplies small lasers from diode lasers to big laser system, for example, femtosecond laser-based amplifiers, and also current caters to industries as well through gas lasers, diode lasers, etc., fiber lasers, etc. So they are one of the largest manufacturers of laser systems in the world. So we also represent now Toad Labs. As everyone is familiar with Toad Labs, they provide a variety of different components and solutions for the scientific market and laser market. So these are some of our leading principles. We also represent other a few companies like Thales, Lightron, and light conversion, Litilit, etc. for different laser sources. Leotech, for example, they are manufacturers of dye lasers. And so we have also recently added a few new companies like Qnami, who are making quantum microscopes, and also Honest Technologies, who are making cryogenic nanopositioners. So these are some of our principles. So this is our team. This was taken during our last annual meeting in Goa. And we have made an efficient structure to support and provide the service to the scientific community. And with this, we are able to bring more into the market through sales and service. So quick look at our service team. These are our service team. So total number of 6 service engineers plus 1 service coordinator to provide efficient after-sales service for all every system we supply and install in throughout the country. So as you can see, they are some of the most experienced laser engineers in this field, and it's not just them. So our entire team is mostly focused on the systems which we represent, and they are also even for example, sales team is also trained in some part of the systems which we represent. So we are able to provide service and application support through our sales team as well as service team. So our institutional coverage is throughout the whole country. As you can see, so we have our presence in almost all the IITs, NITs, IIC, ISOs, etc., major research institutes, research and development institutions, and also private research companies as well. So over the time, we have provided almost like thousands of systems throughout India, both in the private sector as well as in the scientific R&D institutions. So the numbers are here are like just a small part of what we have provided. So for example, 200 hexamer lasers, 40 number of femtosecond amplifiers, 3 number of terawatt lasers, and 1 petawatt laser installation in our lab. So these are our key scientific markets. So femtosecond laser systems are like one of our key markets where we have a lot of presence. So amplifier seeding, imaging, nanotechnology, LIDAR, science, material science, spectroscopy, and biomedical fiber, OCT, and terahertz spectroscopy. So our key industrial markets are aerospace, glass, semiconductor, electronics, automotive, etc. So our headquarters is based in Mumbai, which has 3 floors, 2 floors of workspace, and the bottom ground floor is entirely dedicated to our app labs, where we develop systems, and also we have a lab for fiber laser facility, developing fiber lasers, etc. And we have a branch office in Chennai as well, which provides service and sales support to the southern part of India. So we have also supplied various systems in both scientific institutions and industry developed by or built by laser science. So, for example, we have supplied welding cladding systems, dual laser 3D printing system, which is at IIT Hyderabad, and anti-drone defense systems. So we have also launched recently a newsletter to keep up with the updates on our activities to the scientific community. And we are also having a significant presence in almost all the talks and conferences and platforms throughout India. So these are some of the activities we have done in the previous year. So in this venue, I would also like to quickly introduce one of the most successful product portfolio, which are the Exama lasers. Exama lasers are basically excited dimer. It is a combination of two gases. It can be argon fluoride, krypton fluoride, xenon chloride, etc. So this laser is mostly in UV range. So these are the models available. So Corin has one of the widest portfolio models available for UV laser, Exama lasers. So these are some of the models. So Existar, which is a very low-end system. These are specifically used for eye surgeries and lens making, marking, and optical sensor manufacturing, etc. So it's a high rate system with very low energy, 1 kilohertz. So the IndyStar, the next in line for the Exama laser model, is used for fast pulse application like inkjet, nozzle drilling, metrology, and optics testing. So this goes up to 2 kilohertz, and it is available in 193 and 248 nanometer. So compacts, which is short for compact Excimer lasers, are mainly used in scientific industry, scientific R&D institutions, and industrial R&D for uh, mainly PLD in India and other applications as well. So this provides a very high pulse to pulse stability and excellent beam uniformity for demanding applications. So the key feature of this is like it can go up to 750 millijoules of energy at 20 hertz. So the main application is thin film processing, wafer processing, and pulse laser deposition. So this concept, this is like for R&D, and Core after this has developed much bigger systems. So once the R&D is finished and it is going into the fabrication industry, industrial production. So the next systems would be ideal for that. So it follows the same high energy, even higher energy than the complex lasers, and also similar characteristics for beam of beam quality, etc. So these series, Leap, Lambda, and Viper, they are intended for industrial manufacturing. The similar results which you get out of the lab can be transformed into a production environment using these lasers. Some of the examples we can give for mass production is like the blood sugar checking strips, which are available in the market now. It is a sort of a gold thin film coating, which is manufactured using these lasers. So the production capacity would be like thousands per second. So a little bit more in-depth view into the compact system. So it's available in different energy ranges from 150 millijoules. But the most popular ones are the 400 millijoules and 750 millijoule laser systems. And it comes with a very high stability of 0.75 percentage. So we'll see this is one of the best in the industry. And for PLD, which is the most popular application in India for these Exama lasers, so it requires high photon energy in UV wavelengths, high output energy, that is the fluence of several joule per centimeter square over several millimeter square. homogeneous spatial intensity distribution, and short-term as well as long-term stability. So, a quick comparison with the alternatives available in the market. So, the alternative available is the YAG laser, uh, which is a solid state laser compared to the XMS, which being a gas laser. So, the gas lasers are being replaced by solid state laser, which are being replaced by fiber lasers in the industry. But some of the older conventional technology lasers are still more persistent in the market because of certain advantages. So we will just quickly go through a few advantages. So one of the advantages is the high photon energy, and the other advantage is the examiners deliver direct UV pulses compared to the solid state laser, which you have to convert. It's a non-linear through a non-linear process, thereby increasing the distability of the system of the beam. So, quick look at the beam homogeneity. Examer being a gas laser with more spectral purity and a uniform beam is much better compared to a solid state laser, which is having a lot of, because of its nonlinear origin. So, it has more issues in like self-focusing and birefringence, etc. in the rods, solid state laser. Uh, so it produces a less homogeneous beam than an XM laser. So, so poor output energy due to conversion losses, which I explained in the previous slide, high pulse fluctuation due to nonlinear frequency conversion. These are some of the issues which are prevalent in the solid state technology, which is not there in the XML laser. So this is a quick look into the laser systems since we are running out of time. So I made it a trimmed version. I hope that my talk was useful. Thank you for your attention. If you have any questions, please write to us. Let us know. Thank you.
I don't see any hands. So let's thank Rizwan one more time. And that's the end of the industry session as well. So thank you to all the speakers for coming over and presenting your systems and